by principle of mathematical induction that sum of first n even natural numbers is n plus 1. That is 2 plus 4 plus 6 plus up to 2n is n plus 1. So given 2 plus 4 plus 6 plus 2n equals n plus 1. So n is a member of natural number. So now step 1. So remember, we have to prove 3 steps. So step 1, show that the given statement is true for n is equals to 1. So show that the given statement is true for n equals to 1. So left hand side is equals to 2. That is the first number. So then right hand side. So if you are showing for n equals to 1, so you consider the first number, n is 2. So now right hand side, we have n plus 1. So remember, we are showing that for n is equals to 1. So this is 1 plus 1. So that is 2. So because 1 plus 1 is 2. So 2 times 1 is 2. So now the left hand side is equals to the right hand side. So for n is 1. So first term here. Then you put 1 here also. So since it is equal, therefore the given statement is true for n is equals to 1. So that is step 1. So now step 2. Assume that the given statement is true for n is equals to k. So you will write all this, just replace n with k. So therefore we have 2 plus 4 plus 6 plus 2k is equals to k plus 1. So k is a member of natural number. So if you are showing that it's equals to k, so anywhere you see n, just put k. So that means you have shown for if it is equals to k. So you will now say, therefore the given statement is true for n is equals to k. So we have shown for step 1 and step 2. So step 1 and step 2 is very easy. So just show that the given statement is true for n equals to 1. So the right hand side is 2 and the left hand side is 2 and right hand side puts 1 because we are showing for n is 1. So this 2 is the first term. So now if you put 1 in the right hand side, you also get 2. So the given statement is true for n equals to 2. Now step 2, it's true for n equals to 1. So step 2, assume that the given statement is true for n equals to k. So you just put k to replace. And remember, in this first step, you can also show that n is true for 2. So it's not necessary to be 1, but for mathematical induction, we usually test for 1. So if you put 2, for example, so it will be 2 plus 4, 6. Then here to put 2. 2 plus 1 is 3. 3 times 2 is 6, so it will be true. So we actually prove for only 1. For n is equals to 1. So we'll be doing for the first time always. So now step 3, that is the step that needs simple manipulation. So step 3, using the assumption made in step 2, show that the given statement is true for n is equals to k plus 1. So using the assumption made in step 2, show that the given statement is true for n equals k plus 1. So left hand side, so we have 2 plus 4 plus 6, so up to 2 brackets k plus 1. It is 2 plus 4 plus 6 up to 2n. But now we say n is k plus 1. So this n, just replace it with k plus 1. Now this expression I have here is the same expression I will write. So that is 2 plus 4 plus 6 plus. So I'll put brackets here. So plus 2 brackets k plus 1. So if you look at this very well, it is this same expression that I rewrite here, but I only put brackets here to cut this. So that is what I did in the next step. So it's the same thing I rewrite, but I only put brackets there. So now if you look at what you have in the brackets, so is equals to, so what you have in this bracket now is like your original question, but it stopped here. So you have to include this to complete it. So that means, but in terms of k, so what you have here now will becomes 2 plus 4 plus 6 plus 2k. So that is what I have in bracket now. Just complete it. Then plus this outside one, 2 brackets k plus 1. So now 2 plus 4 plus 6 plus up to 2k is like your question here. 2 plus 4 plus 6 plus 2n. The result is n plus 1. So if I now have it in terms of k like this, the result will be k plus 1. So that's what I'll write next. So that means I have this is equals to k plus 1, then plus 2 k plus 1. So instead of writing all this, this is the result, k plus 1, because in our question all this is equals to n plus 1. So just write it in terms of k, but I have 2k outside this one. So that's it. So next step, what is common to both sides? So k is common, so I have 2 plus 4 plus 6 plus 2k plus 1 is equal to k plus 1 So that is k plus 1 is here, k plus 1 is here. Factor out 1. So one of it is common. So if one of it is common, that is k plus 1 is common, so it will remain k here and it will remain 2 there. So this will be k plus 2. So now this will be k plus 1. Show the full step. So this is equals to k plus 1, k plus 1 plus 1. Remember this is k plus 2. So 1 plus 1 is 2. So I can say k plus 1 plus 1. So that's it. So now remember that the last proof is that n is equals to k plus 1. So the last proof is that n is k plus 1. So anywhere you see k now, k plus 1, you can put n. So this will become 2 plus 4 plus 6 plus 2n, because this k plus 1 is n now. So it's equals to k plus 1, that's n, brackets another k plus 1 here is n, then plus 1. I have one left. So if you look at this now, it is back to our question. So that means we have shown by mathematical induction that 2 plus 4 plus 6 up to 2n is equals to this. So hence the given statement is true for n is equals to k plus 1. So proved. So finally, so if you have shown that it is true for n equals to k plus 1, so you can now conclude that this plus 2 plus 4 plus 6 plus up to 2n is equals to n plus 1, for n is a member of natural number, is true by P.M.I, principle of mathematical induction. So we have proved. So let's see another example.